Hey friends, it's Lydia and welcome back to the channel. Today's really exciting because we're doing something new. We're launching the STEAM series. Up until now, we've been focusing on do-it-yourself art activities that highlight different STEM principles. And while I'm really excited to continue making those videos, I thought it would be cool to add on the STEAM series to highlight different concepts that are a little harder to cover within a 5-minute video. The idea behind these series is to break down bigger concepts that are a little more complex for little learners or anyone who really just wants to learn more about that particular topic. Now, I won't pretend to be the professional and pretend to be the expert of all of these different topics, but I figured if I can lend a hand in helping understand some of these more complex topics, break them down into smaller ideas that everyone can understand, we might have a better shot of understanding just a little bit more about how our world works. So the first STEAM series is going to be immunology. I am not an immunologist. I do not pretend to know all of the very specific ins and outs of how our immune system works. But my background does lend me to understand a good amount of it, and really I want to touch on the basics. In the current state of our world, I thought it'd be really appropriate to go over how our body fights off infection. Now, again, it's a very complex topic, but I'm here to break it down into 3 simple videos that will help you understand just a little bit more of how our body works. Hopefully, the goal is that you'll have a better understanding of how our body works and thus make a more informed decision about the vaccine. The first video in the series is going to be about our innate immune response. You can think of this like the generic catch-all response. This second video will be about the adaptive immune system. Think of this more like your specialized fighters. The third video will be about vaccines, how vaccines in the past have been discovered, how they work, and hopefully provide a little bit more insight into the new coronavirus vaccine. All in all, I'm pretty excited for this series. I hope you are too. So without further ado, let's go into the video. Our immune system. It's quite elaborate and beautiful, with so much to still understand. Let's start to get into the basics of how our immune system works. First, let's establish that there are 2 big picture parts to our immune system. There is non-specific, or innate, and specific, or adaptive immunity. These 2 parts are pretty self-explanatory. There is one part of our immune system that is generic, and another part of our immune system that is specific and very precise. We'll cover the non-specific, or innate immunity today. There are 3 components of non-specific or innate immunity that we'll cover today. The first is physical barriers. This is the first line of defense to keep things out. The first thing that might come to mind is your skin. Your skin is actually your largest organ, and it does so much. It protects our body from a lot of foreign invaders. Components of the physical barrier you might not think of right away are mucous membranes and stomach acid. Fun fact, you can think of our bodies as a tube within a tube. This often repeated phrase became quite comical when I was in school, but it is true. When we form as embryos and develop, we can be thought of as tubes within a tube. Think about it. The innermost tube is our GI system, from our mouth all the way to our food exit point. You start in the mouth, travel to the esophagus, then make your way through the stomach contents, and the small intestines and large intestines until you eventually excrete solid waste. So, if pathogens, which can be viruses, bacteria, really any foreign substance, enter through our GI system, they have direct access to our outer tube, or rest of our body. Therefore, our mucous membranes and stomach acid are important first-line defense systems our body utilizes to fight off invaders. The second component of innate immunity we'll be talking about today are phagocytes. These are our second line of defense. They're also known as antigen-presenting cells, or APCs. The pathogen, again virus, bacteria, whatever foreign substance, gets eaten up by these phagocytes. They're a type of white blood cell, and then there are many types of these phagocytes. A few of them are microphages, macrophages, granulocytes, and dendritic cells. All we need to know for our purposes today are that they identify pathogens with little receptors. It It then phagocytoses the pathogen, or brings it into a little bubble to break it down. The pathogen is now in something called a phagosome, which is like its own little isolation bubble. Then these digestive enzymes, called lysozymes, pour into the phagosome. Basically, it eats up this virus and breaks it apart to smaller components. These components are also known as peptide chains. These peptide chains, or smaller components, get attached to a protein called the major histocompatibility complex, or MHC. There are two types of MHC, and we are talking about MHC2. That means that there's an MHC1 out there, but that comes a little later, so stay tuned for the next video. Anyways, here's the important part. These little parts of the pathogen get presented back onto the membrane. Can you brainstorm why this is? We'll come back to this. The third part of our innate immune system that we'll be covering today is the inflammatory response. This is also in the second line of defense. This brings the weapons and fighters to the fight. Let's look at this on the big picture level. What does it mean when something is inflamed? Well, that means that there's this redness, swelling, heat, and pain. This usually happens because of mast cells and dendritic cells, which are both types of white blood cells. They're found right under the skin. So, when a pathogen breaks the surface of the skin, let's take for example, like you stepped on a nail or you got a paper cut, those little cells turn on the action. Mast cells release histamines. Does that sound familiar? It might if you take Zyrtec or Claritin. Well, those are antihistamines, which means they fight back against the histamines that the mast cells are producing in an effort to curb an inflammatory response, also known as our allergies. Well, anyways, these histamines released by mast cells make their way through interstitial fluid. Think of interstitial fluid like these squishy, gel-filled parts of stress balls to get to your blood vessels. Histamines affect the cells that make up your blood vessel walls. They cause these cells to separate or vasodilate. That means as your blood vessels get larger, the more porous they become. That means more things can make their way through those walls that normally wouldn't have. So fluid's beginning to collect at that site, so think this is what causes the swelling. Your body begins sending out signals called chemokines, which is part of the rallying cry, telling other cells in your body, we have an invader. So they use these signals to then get more key players to come to the site of action. So that's where we're going to conclude our discussion on the non-specific side of the immune system. Again, this is a very, very basic level introductory video into the immune system. But the goal is that you learn something about how your immune system works. So think about this. If there's a non-specific side of the immune system, there must be a specific side, correct? Absolutely, that's next week's video. Also, in the interim, keep thinking about why those peptide chains, or those smaller bits of the pathogen, get presented onto cell surfaces with that MHC protein. All of those are to be answered next week. And that's a wrap on the Immunology STEAM series Part 1. If you liked this video and you learned something new, be sure to give it a thumbs up and hit subscribe to this channel. Make sure you ring that notifications bell so you don't miss the second part of the series. That's it for me on my end, so I'll see you in the next one. Bye!